Okay. Good evening. Good evening, Vishnu sir.
Good evening, sir.
Hello, Anil sir.
Good evening, sir. Good evening, sir.
Good evening, sir.
Shall we start or wait for 5 minutes?
Good evening.
Yes, we shall start, sir.
Good evening to all. Is audible? My voice? Hello? Yeah. Uh, Good evening to all. I am very happy to welcome our resource person, Professor Vishnu Nambudiri. Professor Vishnu Nambudiri needs no formal introduction, as we know, everyone knows in the mathematical community. He is very well expert in number theory and representation theory. But it is my duty to introduce him formally today. Professor Vishnu Nambudiri obtained his PhD in 2009 from University of Hyderabad. And number theory and representation theory are his area of interest. And he worked as a faculty in the University of Hyderabad. At present, he is working faculty in Kerala State in Government College, Chittoor. And we already conducted 2 workshops, and Professor Vishnu helped us as a resource person in these 2 successful workshops that we conducted earlier, one in Python and one in LabTech. And the Department of Mathematics is very grateful to him for his constant support by providing as a resource person in this field of LabTech and research software and in mathematics. And I take this opportunity to thank our Professor Jayaraj and our beloved head of the department, Professor Anil Kumar, for his constant support and encouragement. I welcome all of the participants for this workshop. I hope it will be very fruitful section. Now I hand over this mission to our resource person, Professor Vishnu. Thank you all. Sir Vishnu.
Okay, thank you very much. Am I audible to all of you?
Yeah, it is.
My volume, the sound is sufficient, right? Because most of the times what happens is that I start speaking for a few minutes, and after that only I realize that my voice is not at all audible to anyone. So that's why I'm asking in the beginning itself.
Now it's clear.
Okay,
Clear.
thank you. So this is, as Dr. Prasad already pointed out, that this is, I think, the 3rd workshop that I am attending as a resource person for the University of Calicut in the recent years. One was in LaTeX, the other one was in Python, and this one in Sage Mathematics. So I'm very thankful to the university for inviting me to give a few lectures here in this workshop. So the very first thing is that I think Professor Anil Kumar, he has been very much fond of me, inviting me to give talks here in a series of workshops organized by the University of Calicut in software related things and mathematics related things. Thank you very much once again to the department. So the Sage Mathematics, many of you might have already heard about the software Sage Mathematics. Sage Mathematics, SageMath in short, previously in short called as Sage. After that they changed the name to SageMath. There is a computational package available in mathematics for performing many of the computations that we may require in medium level mathematics as well as high level mathematics. I am not saying low level mathematics because there is nothing called low level mathematics, as we can say, because almost all mathematics is serious. At least it must have the medium kind of difficulty, and if not medium kind, it's going to be really difficult. So performing computations in mathematics is actually very essential, because even whenever we try to do something, whenever we try to develop some theory related to mathematics, it's always essential that we should see that how the examples in that particular theory evolve properly. Because without seeing examples, how the examples are working, and sometimes examples actually give us an insight into the theory itself. Most of the times that's what in serious mathematics that happens. We try to do something, we try to see a few examples. From these few examples, we try to understand that something is really happening, which will finally lead us to give a theorem or a statement which we try to prove at least. So this is the way in which mathematics is actually working. Mathematicians are actually working. Therefore, it's essential these days that one should try to understand something, some tool for computation. Because most of the times what happens is that, of course, in the previous generations, mathematicians tried to do everything by their hand. Of course, they were largely successful also. For example, the famous prime number theorem, which says that number of primes is of the order of x by log x. That was verified by Hadamard, etc. By hand. It was not using any software. Software is not. To be frank, we cannot say that software is actually essential for mathematical computing, but software really helps. Okay, so for mathematics, creation of mathematics or doing mathematics, what is essential is actually, as the old saying goes, that pen and paper. That's more than enough. So nothing more than pen and paper, and of course the working brain is required for doing mathematics. But these days what happens is that since we are doing a lot of computations, we are trying to develop something using computations, it's a very good advantage that if one knows a mathematics package. So that's why we try to understand some mathematics package at least. Okay. So now coming to SageMath, the very first question is that is SageMath the only one mathematics software available for performing computations? The answer is no. And there are many alternate software packages available for computing. For example, one software like Mathematica is already there. Many of you might be already familiar with Mathematica. And Maple is there. I don't know that how many of you will be familiar with Maple. Mathematica is something that many of the differential equation people usually use for their computations and for many other purposes also. And many of you, probably if you are working in some engineering stream or if you are related to applied mathematics mainly, many of you might have already encountered another mathematics software called MATLAB. MATLAB is not purely a mathematical software, we cannot say that. Of course, you can perform computations using MATLAB. MATLAB is matrix laboratory and it is specially designed for engineering purposes. So for mathematics related computations, people usually prefer Mathematica or Maple. But these two software, naturally we know that doing mathematics is difficult. Therefore, developing a software for computing in serious mathematics definitely is going to be difficult. Because of the difficulty of such a thing and because of the specialization that require in developing such a software, the softwares Mathematica, Maple are really heavily priced. So you need to spend several lakhs for purchasing a single license copy, and that also most probably will last for 1 year, 2 years, etc. These days they are providing yearly licenses, not eternal licenses. So previously we used to have eternal licenses in the sense that once you acquire a license, you can use it for lifetime. You will not get any update. You will not get the newer versions. You have to stick with the old version itself. But these days, what happens is that in the sake of reducing the price, they offer these yearly license versions. So they will reduce some price of that particular software. But the thing is that after a year, you may have to renew it. Otherwise, it will stop working. Okay, such difficulties are definitely there. But SageMath software, the special thing about this SageMath is that SageMath software is an open source software as well as a free software. So whenever you think about open source software, you need to distinguish between free software and open source software. Okay. Not all open source software are free, not all free software are open source. Both these things are there. So open source simply means that the source code using which the software was developed is visible to all of you, is accessible to all of you. You can modify such a software according to your liking. You may create your own newer software, etc., etc. That doesn't mean that software is available free. For example, one of the most famous operating system in server business is known as Red Hat Linux. Red Hat Linux was previously used to be an open source as well as a free software, but these days it is still open source, but it is not a free software. So these two things are entirely different. Don't get confused with these two ideas. Open source as well as free are not the same. But as far as SageMath is considered, both these things goes together. It's open source as well as it's free. So open source means that you can modify, you can add your own code to that once you find a special function which is interesting to you. If it is not already available in the SageMath, you can add your definition to that particular SageMath library so that will be accessible to everyone whoever downloads, uses the SageMath software from that particular point of time onwards. And free in the sense that you can download that particular software free of cost from the SageMath website. You can distribute it as well to anyone that you like. So the very first thing that I would like to show is the website of the SageMath software from where you can download this SageMath software, especially if you are using and probably many of the people are using Windows based operating systems. I would like to say that the SageMath software, just like the LaTeX software, many of you might be using LaTeX software. Maybe most of you must be using this LaTeX software. You might have already seen that if you are using LaTeX software in Windows, sometimes even in the installation itself, there are certain obstacles. So you need to really work hard to put this LaTeX into work inside a Windows machine. But in the case of Linux, the situation is completely opposite, because using the built-in software downloader, built-in software installer, you can simply download and install LaTeX software in a Linux operating system, provided that you have a decent internet connection. Just like that, SageMath is also downloadable to Windows, downloadable to Mac operating system, downloadable to Linux, everything, but it works mostly in its home ground, which is the Linux operating system. So it will be much more convenient as well as natural if you work in Linux using SageMath, but it is not definitely required that you need to work in Linux itself. You can run SageMath in Windows also. So I will show you that a screen, a window from where we can download this SageMath software. Let me just start sharing that screen. So you can see this window, right? So one request is that if someone can say at least yes or no whenever I am asking for something. The good thing about that is that if you are typing a message, I may not be able to see, because I am shifting the window. I am focusing to some other window. I may not be able to see that what exactly you are saying. Even if you are messaging, that also I may not be able to say. I may not be able to see. Hello? Okay, so why I am saying this is that sometimes it has happened that I keep on speaking. Only after 5 minutes I realized that my internet was disconnected. So I was doing something, I was showing something, I was speaking to someone, but suddenly I am realizing that my internet connection is actually not there. So I was speaking to no one. So that can actually happen. That's why I'm saying that whenever I am asking for something, for some clarification, if you are hearing, please. Just say one word, yes or no, something like that. No need to say anything elaborately. No need to post any messages. Messages also I may not be able to see. That's why. Okay. You are able to see this SageMath search page that I have opened in Google Chrome, I guess. Not in Google
Yes,
Chrome.
sir.
This
Yes.
is in Firefox.
Yes.
Sorry. Yeah. So if you go there, directly there, this is the website of this SageMath software, sagemath.org. You can see directly giving a Google search command will open this page. So it says that there are different things appearing. One is CoCalc instant Sage worksheet. That is one thing that you can see. The other thing is install 9.7. The SageMath 9.7 seems to be the latest available version as of today. So feature tour, help, documentation, lot of things are there. Search, you can find a lot of things about SageMath. So on the top of that, you can see some description saying that SageMath is a free open source software licensed under GPL, General Public License, I guess. It builds on the top of many existing open source packages, NumPy, SciPy, Matplotlib, SymPy. You can see that these packages might be familiar to you if you have already gone through one serious course in one mathematics course in Python. Okay, numerical Python, scientific Python, Matplotlib, matrix plotting library, symbolic Python. These are all Python packages. And Maxima, Gap, Flint, R, and many more. These are some different packages. So access to their combined power through a common Python-based language or directly via interfaces or wrappers. We need not worry about the technicalities on all these things. What I want to stress is that, see, the software, SageMath is not actually a software in its own. SageMath was created using several different softwares. So SageMath bundles a lot of software. Whenever you are asking SageMath to do one particular computation, what happens is that it captures that particular command and feeds into some other software package which is already loaded inside this SageMath system. But the difficulty, if you are using, you may be thinking that why can't I directly use that software package instead of going to SageMath and asking SageMath to connect to that particular software system. For example, suppose that Maxima is a software system for finding for performing certain computation, but instead of directly going into Maxima and instead of asking Maxima to perform some computation, why should I come directly to SageMath? Why should I go to SageMath and then connect to Maxima? The interesting that the answer is that SageMath actually gives you one unified language interface for connecting to all this. Okay, because Maxima may be using one particular command structure. Different software uses different command structure. For example, Mathematica uses a programming language which is not which is not very close to. Of course, they are all close to different languages, but not exactly. It will take some time to learn that particular language and start doing something. So, if you want to do several computations, if you are trying to use different software, you need to understand the philosophy and the structure of commands in all this software. But if you are coming directly to SageMath, the good thing is that one simple language, style of doing language is enough for understanding SageMath. Using SageMath, you can perform all the computations. And another interesting thing about SageMath is that SageMath is using something known as one of the most popular programming languages, Python 3 as of today. Python 3.x. So if you are familiar with Python programming language, it will become much more easier. Doesn't matter even if you are not familiar with Python programming language, you need not worry about that thing because we can easily capture how exactly we are doing it in SageMath. So getting, so there are several help texts also available here. Like many of these things are free to download. Sage for undergraduates is an extensive textbook for Sage mathematics. Mathematical computation with Sage is another one. So there are several things. If you want to download, you can directly go to this GIT hub, or you can directly go to this direct link to use Windows is already here. So I am clicking on this. If I go to this, what happens is that You can search here. You can find out one binary file, a big file. I think it must be of the size of the order of 1 GB to 2 GB size. Okay, but these days it's not very difficult to download a 1 GB file. Previously it was really difficult. 1 GB is a huge size. It was a huge size. These days it's not. You can download that Windows-based software. You can install it as you install any other software in Windows. In Linux, as I told, the installation is mostly done using directly going into the software package manager and installing. That doesn't matter. Most of the things you can easily Google and find out. I'm just saying because you should understand that such things actually exist. I'm not going to explain all these things because that is not what we actually want to discuss today. So once you install this SageMath software, you can access it using the URL start menu, desktop, some icon like SageMath will be appearing, an icon something similar to this one. This Sage you can see. This something similar to this one will be appearing on your desktop. You can directly click on that and you can access it. That's how SageMath installation as well as opening. So if you do not want to install SageMath immediately, you want to experiment something with SageMath. So there are two ways to do it online. One is known as CoCalc. CoCalc is an instant Sage worksheet. That is a little bit advanced SageMath computation online server. But the difficulty with SageMath, using SageMath and CoCalc is that CoCalc is deadly slow for free users. We can try to see CoCalc. Okay, this is the link, CoCalc. Let me just click on this link. Wow, what is this? Okay, I'm just deleting all these things. CoCalc, that's it. Okay, I'm already logged into this. That's why you are seeing that signed in as my name is appearing there and my URL is also appearing here. So if you want to, let me just try to log out from this. This is the CoCalc page. You can create an account for free, but as I told, free accounts are really restricted. You will not get much software, much server space. Sometimes they will say that you cannot run this program right now because our server is already busy. So once you are logged in, you can, this is where to log out. I'm just checking where to log out. Okay, let me sign out so that I can show it from the beginning itself. So this is where you are landing. Okay, this is the CoCalc homepage. So either sign up using their terms and conditions. You can see that cocalc.com. So if you have already opened your computer, if you are watching all these things in your computer, you may please try to open another window in which CoCalc can be opened so that you can also try. So without trying also, you can directly go inside with a guest account. Okay, no need to actually log in. Sign in, try CoCalc. Use CoCalc anonymously. You can see that from the home. I clicked on try CoCalc now. Okay, this is what I did. So let me try to use it anonymously. After that, I need to go to my projects. Okay, I'm starting a project. It's loading. So it says untitled, the project title. Okay, whatever it is, let us accept it as it is. But see, this is the problem. So whenever you try to go to CoCalc, what happens is that too many trial projects, some messages like this will be appearing here and there, so that CoCalc right now paying customers have priority. You try running your trial project later, or some message like this will appear, and this will actually discourage you from doing anything. So the best thing is actually to load download SageMath into your own system and try to install it. Okay, that's the best thing. So just Google that SageMath for Windows or SageMath for Linux. SageMath for Linux can be downloaded using the software installer available in your Linux system. Most of the people will be using Ubuntu based operating systems or sometimes Linux Mint based operating systems. In both these systems there is a software manager available using which you can run this SageMath software. You can install and run. You can install using this software manager and run the SageMath software. Okay, now instead of this, since this is taking a lot of time, instead of this I am going to another SageMath online server which is always accessible, which never lets you down. That is known as Sage Cell. Sage Cell server. Okay. This is not like Kokal. This is a different thing. I will show you what exactly the difference is. So this is where you are coming. Now SageMath Cell, this is a very simple interface. There is no login at all, nothing. So okay, suppose that you want to try to perform some computation directly here. What type of computation we should perform? Suppose that we try something very simple. 2 plus 5. I typed just this and I'm clicking on evaluate. So the result is appearing here. Okay, you can try that. Some of you may try. Just try to open Sage Cell. Sage Cell. It's here. Now 4 star 8 for multiplication. Evaluate. It's taking some time basically because we are running it using some SageMath cell server, not directly in our system. If you are running it in our own system, it will not take time. It will be very fast. Most of the computations are fast. Of course, there are certain computations which are slow. Now 4 star star 3. So this is exponentiation. It gives 64. Instead of 4 star star 3, just like in the LaTeX style, you can use 4 to the power 4 caret 3. That's also usable. 64. Okay, these are some simple computations that we can perform using the SageMath cell server. But now I am not going to use the SageMath cell server basically because I have already installed the SageMath system in my local computer in which I am sitting right now. And not only that, the difficult part of performing computation in SageMath cell server is that whenever you close this window, your computations are entirely lost. Okay, you cannot retrieve the computations. You are closing and you are leaving. That's it. There is no user account kind of thing. But instead of that, if you are using our own installation, something like this will be appearing. Okay, you can see that on the top of that some Jupyter is written. Several directories are listed here. I can click on these are the directories in my local system. So I have already opened. This is the home page of the SageMath system. On top of that, SageMath is not appearing, but Jupyter is appearing instead. Let me open one folder and I will be saving my computations there. I have opened. So I clicked on one of the document folders. Now I am going to create new SageMath, my system. SageMath is 9.5, not 9.7. It's a little bit old version. I am opening SageMath, a new SageMath 9.5 file. It comes. Okay. So this is a little bit different from what appears in the what appears in the Sage Cell server. So again, exactly the same kind of computations let me perform here. 4 minus 9. But there is no evaluate button here, you can see. But instead of evaluating, what I can do is I can try to click on run. Minus 5, 9, star, star 2 exponentiation. Run. 81, very fast. 9 to the power 3. Latex style. 7 to 9. What else? 9. Exponentiation is double star or hat. Double star without a space. So this is not going to work. This may create, okay, let me see. I'm just saying, that's not working. So there is an error, like that's invalid syntax. So this double star is a single operator, and you need not keep double star very close to 2 or very close to 9. I think you can keep it like this. That will work. Okay. Now 9 percentage 2 or even 4. Run. So 9 percentage 4 simply means that you are dividing 9 with 4 and taking the remainder. Okay, you are asking for the remainder. Remainder as per the division algorithm, that if B is dividing A, we will be able to write A is equal to BQ plus R by B is positive, and the remainder lies between 0 and 1. Sorry, 0 and B. So this is the remainder operator. Now there is another operator called 5 by 2, you can see, division. So I did not click on this run. Instead of that, I pressed Control Enter. Okay, I pressed Control Enter. If I press Control Enter, what happens is that the result will be appearing, but no new cell. This is not as a cell. Okay, wherever we are typing something, that's not as an input cell. Whenever you are typing something inside a cell, that's not as an input cell, and that is marked with the number in 7, input cell 7, out 7, output 7. So, yeah. Sorry, is there any question?
Sir, how to install this Jupyter notebook?
This is basically SageMath only, not Jupyter.
Okay.
Jupyter is Jupyter is the interface using which SageMath is running these days.
Okay.
Sir, please excuse me, sir.
Yeah.
Sir, kindly, it's my request, sir, kindly go to SageMath org one more time, and how to reinstall or how to download the can.
How to install in Windows machine you want? No?
Yes, sir. Yes, sir.
Windows machine, right?
Yes, sir.
Okay. Let us
Please
before
go
proceed.
one more time, sir. Please.
Okay,
Sir. Yes,
before proceeding further. Okay, that's okay. That's not a problem. Before proceeding further, let us just try to see. So SageMath Windows. Windows installation is really easy. There is not much to worry about Windows installation. So for that, you just go to sagemath.org download. You can see that download. There is a download link. Exactly the same page. Okay. Now after going to this download page, what happens is just one second. Development, not development. We are not interested in the development. But instead of that, yeah. Install from pre-built binaries. 1 second. Let me just try to see where exactly it is. Okay, I think only up to SageMath 9.3 has been ported to this SageMath. I will show you that link. I was just searching where it is exactly. Okay, it's here. So you need to go to GIT Hub. I will paste you. So this is the link for getting that SageMath binary. So from here, what you can do is you can download this is the latest thing available. This is a 2021 version. I don't think that after that they have updated this SageMath using this particular technique. They are using something called install Linux inside Windows, some kind of a difficult technique they are using these days. But instead of that, SageMath 9.3 is good enough for doing any kind of computation. So if you go here, you can see a file here, SageMath 9.3 installer, right? You are able to see this, I guess. So if you click on that, you will be able to download one installer file, exe file. Download this exe file, clicking on that. So it's downloading here. So after saving this exe file, what you have to do is you need to just go to that exe file, double click on that and click on accept, proceed, etc. as usually you install any Windows software. But the link you need to really remember that this is the link. So I am posting this link here. This is the link for downloading that Windows binary, Windows exe file.
Sir, can you tell me what is the way to install in the Linux operating system?
Sir, which Linux operating system you are using? Ubuntu you are using?
Ubuntu.
Huh?
Ubuntu
You are using. In case you are using Ubuntu, what you have to do is you have to go to the software manager.
Okay.
Okay. When you click on the application menu, you can find the software manager. Just search for SageMath.
Okay.
Keep it connected for at least 30 minutes, provided that you have a very good internet connection. If you have a 100 Mbps internet connection or something like that, it should not take more than 10 to 15 minutes.
Okay, sir.
Then after that, what will happen is that on the desktop itself, or not in the desktop, because in Ubuntu nothing will appear on the desktop. So in the application menu, when you search for SageMath, that link will be there.
Okay, sir.
If you click on that link, a window like this, this will be opening up. On the top of which Jupyter will be appearing. Don't get confused. This is actually the SageMath window. This is not actually the SageMath window alone. Using this Jupyter window, you can create several things. You can create a Python 3 file, text file you can create. This is the unified interface for creating files. Okay, Jupyter is not actually something what you call particular to SageMath, but SageMath has stopped developing any specific windows for their own calculation purposes. They are using Jupyter straight away. That's it.
Okay, sir.
Okay.
So means that if I install the SageMath, then I from that application I can run the Jupyter and can do the work.
In the applications you will not see Jupyter. In the applications you will be seeing only SageMath.
Okay.
The SageMath link with SageMath icon will be appearing. If you click on that SageMath icon, instead of SageMath, you will be seeing this Jupyter window. That's what I'm saying.
Okay, sir. Okay, thank you, sir.
And after going into that, then you need to just create a new file, new SageMath 9.5 inside that Jupyter window.
Oh, thank you.
Okay. So after opening a new window, something like this will be appearing. On the top of that, some untitled will be there. Untitled, you can change it to whatever file name you like. And remember that this file will be saved as an IPython notebook. These are technicalities, don't need to worry about these things. This file will be saved into the directory which you have previously opened. See, I have opened the documents folder. So whatever I am typing afterwards, whatever file I am creating standing inside the documents folder will be saved inside the document folder. So this is the first file, CU workshop. I'll put a date also, 2022 12/08. This is day 1. 01. I'm giving this as the file name, renamed. On the top of that it will be appearing. Okay, that's it. Okay, now what I'm saying is, if you type 5/2, you can either click on this run to execute it, or you can press Control Enter. Okay, or you can press. Okay, there is a small difference. I'm pressing Control Enter. You see this? Control Enter I pressed. Or I can press shift enter. So can some of you make out what is the difference between control enter and shift enter? Lastly, I press shift enter.
Shift enter is by using the shift enter, we can also run a code.
By using the shift enter, I have opened.
Shift plus enter.
Yeah, I have opened another input cell.
Acha, okay.
Yeah,
But whatever
opened.
in a block, in a particular block, we are writing a code. So after like
exactly.
3*4, like 3*4, we are writing. So by pressing the shift plus enter, we can find like output of 12.
Sorry, I didn't get that.
Like we are writing a code in a block, like
yes,
3*4 means 3 into 4.
Yes.
Then by pressing shift plus enter, we will get the output 12. So
Okay.
we can run that particular code without clicking on the ring run.
See, shift enter, what's happening is the code is executed, the computation is performed. Not only that, Sage will open another input window, another input cell for entering a new command. Okay. See, 3 *5, 3 to the power 5. I am pressing shift enter. You just see, I am pressing control enter for the first time. I am pressing control enter. Control enter will show you the output, but there is no more input cell to put any command. Okay. But if I am pressing shift enter, result will be displayed and a new input cell will be appearing. That's the basic difference. If you press run, then also a new input cell will be appearing. So clicking on the run, clicking on the shift enter will execute the command, perform the computation, as well as it will open a new input cell for accepting input commands. But pressing on control enter will simply execute it. No new input cell will be created. But then if you want to create 3 to the power 6, I am pressing control enter. So then how to create an extra cell? Then for that you have to if you have pressed control enter and you have not got a new cell, you need to go to this where is that, insert. You need to go to this insert command and insert cell below. That's it. If you used control enter and you did not get a new cell, you can open a new cell using this insert command on the top in the Jupyter interface. Okay. Now another thing is you have already saved this file, but suppose that you want to send this file to someone showing your computation. These are all simple computations, of course. Suppose that you want to save this computation to someone. For that you can go to this file menu and download as a LaTeX file, PDF file, any of these things you can do. Okay, you can download as a LaTeX file. LaTeX code will be given to you as a PDF file. There are different ways for producing the PDF file, but we need not worry about these things. Provided that LaTeX is installed in your system, a PDF file will be created through LaTeX, through running LaTeX command. So you can save that file and you can send it to anyone for showing your computations, because the file you have saved will be in the a different format which will not be readable by others if they have not installed the SageMath software. Okay, so then you need to send the PDF file or the HTML file that you are downloading using this. Okay, that only you should send to others if they are not having this SageMath software installed. Now, I think I forgot to say one more thing. I was starting to say that thing. So 5 by 2, okay, 5 by 2. The result is just 5 by 2, right? It's not giving any numerical approximation, numerical answer. Now, what is this 5 by 2? What is meant by this? The result is 2. This simply means that just like taking the remainder, here we have taken the quotient. Okay, 5 by 2. Okay, 5 by 2, the integer part is taken here. What is minus 5 by 2? Minus 3. The greatest integer not exceeding minus 5 by 2. That's what this symbol is. 5 double backslash, or double, not backslash, double slash. 5/2 simply means that you are taking the greatest integer, you are dividing 5 with 2 and taking the greatest integer not exceeding that particular number. 5/2 is 2.5. The greatest integer not exceeding 2.5 is nothing but 2. Minus 5/2 is minus 2.5. The greatest integer not exceeding minus 2.5 is nothing but minus 3. So that's why the answer is there. Okay, I hope that these things are clear to all of you. These are all basic mathematics, arithmetical operators available in mathematics. We have seen how to use all these things. Addition, almost all basic mathematics operators are available here. Addition, multiplication, remainder operator, taking the integer part. These are two special things. Remainder operator as well as the integer part thing is not usually available in the usual calculator, but it's available here. Okay. Now, so I hope that this much is clear to all of you. Now, if you perform sequential computations, what will happen is that 4 to the power 2 plus 5. So this will be interpreted as usually as 4 square plus 5 because exponentiation has highest priority. Okay, exponentiation takes the highest priority. The usual mathematics rules are accepted. Usual mathematics rules in the sense that exponentiation parenthesis opening brackets takes the highest priority. After opening the bracket, what happens is after opening the bracket, this exponentiation takes the next priority, and after that plus minus all this takes the next priority. After exponentiation, multiplication and division takes equal priority. Multiplication and division takes equal priority means that whenever multiplication and division both are included on one line arithmetic, so left to right evaluation will be performed. Whatever is coming on the leftmost side, that will be evaluated first. Okay, multiplication and division, they have the same priority. Addition and multiplication, they have the same priority. Left to right rule is applied when the same type of operation, same priority operations are appearing on one line. Left to right rule is used. Okay, that's the operator precedence. Now, another interesting thing that I would like to tell about is that suppose that I am performing two computations in the same cell. So if you perform one computation 6 plus 7 and just simply press the enter key, no shift enter, no control enter, then no evaluation will take place, but the typing will go to the next line. Okay, 4 star 3. Suppose that I run. So what's happening here? I am seeing only 64, right? 6 plus 7 is not appearing here. That is because whenever you perform two computations inside the same cell, usually only the last computation result will be displayed. But that is actually odd, right? That's an awkward thing. Because we want to see all the, we cannot write each and everything on different cells. But we want to see the output of all the cells. But in that case, you need to use something known as a print command. Print in bracket. Print in bracket. So what is the output? 1364. Print, P-R-I-N-T. Remember that everything is in small lowercase letter. Do not use any capital P. If you use capital P, there is no such command in Python. This will raise an error. You can see it here. I am typing capital P, running. Name print is not defined. So everything in Sage that follows the Python type of error messages. So whatever word, whatever symbol you are typing is known as a name. Okay, not a variable, it's a name. For creating a variable, okay, we are yet to come to variables. This is the print command, and print print, everything must be in lowercase, small letter. That's the most important thing. Okay. Right. So now we move to some basic functions, because without understanding functions it's really difficult to, and even before going to basic functions, but we will try to see one more thing. So 5 by 2, the result was just 5 by 2, right? So what did you actually expect when you type 5 by 2 as the answer? Not 5 by 2 just like that, right? So what happens is that whenever you try to perform some computations involving rational numbers, Sage will always return the result. Sage will always try to return the result as a rational number. 5 by 2 is just returned as 5 by 2 because the SageMath is rational number friendly. It doesn't consider 5 by 2 to be something that needs simplification. Okay, 5 by 2 is simply 5 by 2. For example, suppose that we add 5 by 2 plus 7 by 2 or 9 by 2. Run. Oh, it's 7, sorry. 5 by 2 plus maybe 6 by 2. The answer is 11 by 2. Therefore, whenever it's possible, SageMath will try to give the result as a rational number. Instead of rounding it off to something decimal, it will always give the exact rational value. Now, if you want to find out the decimal value, then you need to apply numerical approximation. Okay, so for example, 5 by 3. If you simply type 5 by 3, you will be getting only 5 by 3. There is nothing special about that 5 by 3. But instead of that, you can use numerical approximation. Numerical approx 5 by 3. 1.6667, etc. Okay, numerical approach. I wanted to ask you one thing. Previously, with the previous workshops, what I have been doing is, this time I did not do that. What I have been doing was, whenever I was typing some code, I was copying the code and I was pasting it to a Google document, and I was sharing that Google document with everyone. Do you want to do that this time also?
Sure, sir.
Yeah, the good thing with that is that you can, instead of you typing all these things, you can copy and paste those things to the SageMath, the Sage Cell server. Okay, you can try all these things in the Sage Cell server. If you have not installed SageMath, you just open Sage Cell, and in the same window itself, you keep on copy and paste this data. Delete it, because you already have this Google document with you, so you are not losing anything. Later also you can find out that command, but just for experimenting, I shall open a new Google document and I shall share it now itself. Just 1 second. I forgot to do that actually. Okay, let me open a Google document. I'll share that link with you after that. You need a Google Sheet. Sorry, Google document, right? Yeah. I will give the same name as this file, so that it will be easy for you to identify. Okay, let me share. So I'm pasting it here. So this is the Google document where I will be copying and pasting everything, every comment. Okay, for example, I will copy and paste. So what you can try to do is you can open what you call a SageMath cell server here. Sage cell. Open a Sage cell. Paste the command that I am giving here and try to evaluate. You can see yourself. Okay, for example, this numerical approximation. If you try to paste it here. Okay, even before that, I will paste it to the Google document. Okay, the Google document is pasted. Numerical approximation 5/3. You copy and paste it here and evaluate. Okay. Okay, the next command is, okay, this numerical approximation, you may be thinking that this is a very long name, but instead of using this long version, you can simply use capital N of 7/2, capital N, that's good enough. And even small n also should work. Enough. And you can control the number of digits as well. You can control the digits using this command. Okay, I'll copy and paste all these things. That's one. This is next. And this is another one. Everything I copied to Google document. You please try. After typing a few commands, I will give you one or two. I will just pause for 1 or 2 minutes so that you can try these commands yourself. Okay, I guess that you have all tried these. And there are some named constants as well, like n of pi. Pi we know, right? 3.14. But if you try to look at n of pi, these many digits we will get. Maybe we can even try n of pi digits equal to 100. See that there is a comma here. After pi, I am specifying the number of digits parameter here. So 100. That also will work. And n of e. Maybe even n of e square. Or let's just e. Okay, just like that, the sign function you can directly access using the word SIN, sign, SIN. Sine pi by 2. That's 1. Sine pi by 4. See this. It's trying to give the answer as much as accurate possible. 1 by 2 in the square root of 2, which essentially means that 1 by root. Oh, that's the way Sage is representing things in its library. Sine pi by 4. And if you want the numerical, there is one more thing, that if you try to use the show command, show sine pi by 4, see the effect of that. Show, which will give you a neat mathematics output. Okay, show command. Yeah, I have copied and pasted that. Now just like that, show, no need to show, cos pi by 6 root 3 by 2. So 1 by 2 into root 3. That's why it's appearing like that. So you can see that the square root function is denoted using SQRT. SQRT of, okay, before that, cos pi by 6. Or you can even show root 3 by 2. Square root of 16, 4. Square root of 20, 2 square root 5. 2 into root 5. So the square root function. But he is giving only the positive square root. Okay, there are ways to get both roots. Pasted all these things to the Google document. Now square root 20 so if you give the extra parameter all equal to true, it will show all the roots. Okay, both the square roots. Or if you want to use show, once again, okay, please try. So the other trigonometric functions also can be simply tried like this, like tan and see you might have observed one more thing here, right? So you can see that the values 2 root 5 and minus 2 root 5, both these things are given inside a square bracket and they are separated by 1 comma. Okay, even if you don't use this show, it will be appearing like that. Okay, so some values separated by comma enclosed in a square bracket is known as a list in Python. Python as well as SageMath. List. Its format is A dot B dot C dot D, etc. For example, suppose so we can define variables like this. Suppose that I put L is equal to 1, 2, 3, 4 or 1, 2, 3, 5, whatever it is. So if I ask to print L, so this is known as a list. Okay, list simply means that certain items enclosed in square brackets separated by comma. Okay, now can you find the square of a list? Is it possible? Just like square of a variable. No, that's not possible. That is not allowed. Okay, you cannot square. Then what else you can do with list? So let me just copy paste. List. And to create the error, if you want, create it. I hope that some of you are at least trying all these things in the Sage Cell or SageMath CoCalc server. So otherwise, you will easily forget that what exactly we have done. Okay, it's better to try it along with me. If you're trying it, you will be definitely able to understand it much more better. Okay, so let us go to the next topic. So before going to the next topic, I would like to tell a few more things about the list, because that is one of the most important constructs available in Python, list. So list, we have already seen that we define list using L equal to something like that. L equal to, in square bracket we are writing a few values. Now we can access each and every element inside list like this. Suppose that we use L square bracket. So remember that L is nothing but, what is our L? L is nothing but this. Okay. Now suppose that I ask for printing L of 2. I will change this to slightly something else. 2, 6, 11.5, 5 by 3. I'm changing it like this. Now, I am asking SageMath to print L by 2. So what is the result? Print L of 2, sorry, not L by 2, L of 2. What is the result? So 11.5 is appearing, but with some extra zeros here. Okay, let us try to ask something more. L of 3 or L of 1. Yeah, L of 1 is 6. See that L of 1 is not 2. Okay, L of 1 is not 2 but 6. That's basically because in programming language and most of them, counting starts with 0. Therefore, the first counter is 0. So print L of 0. That's 2. Therefore, 2 is nothing but L of 0, 6 is nothing but L of 1, 11.5 is L of 2, and 5 by 3 is L of 3. Okay, this is how the elements in a list are labeled, are accessed. Fine. So we can do several computations on this list. For example, suppose that we simply write in L. Okay, I will copy and paste. Sorry, I forgot that. Copying and pasting to the Google document. L is defined. L of 1. You may try all these things inside the same Sage cell input window. Okay, now copied and pasted, you may try the Google document. So if you are lucky enough, you will be able to open a CoCalc window and you can save all these documentations there. But only if you are lucky enough. I don't know whether SageMath server will now permit or not, because what they are saying is that their server is extremely busy, so that free users cannot be given any more server time. That's what they say. Okay, I hope that you have already tried these things in the SageMath, in the Sage server. I'm continuing with more commands. Now, I have given L equal to this. L is known as I have given I have assigned the list 2, 6, 11, 11.5, 5 by 3 to L. Now this is L is known as a variable, and to L I have assigned a value. Okay, so this is how we actually assign values to variables. For example, suppose that we want to assign just like doing in mathematics, suppose that we put A is equal to 5 and B is equal to 4. Suppose that we want to find out the area of a triangle. Or not a triangle, let us say a rectangle. To find area of a rectangle, suppose that A and B are the sides. We know that the formula is that area equal to A star B. Now print area. Okay, it's a standard a trick that we do in mathematics. Standard way of writing a problem, solution of a problem, in fact. Text. But now, suppose that you change the value of this A and B to something else. Suppose that A equal to how much? 6 and B equal to 7, and you print area. What will happen? What will happen? Again 20 is printed, because the area, here you can see that this area equal to A star B is not actually a formula. Area is equal to A star B is actually an evaluation. Whatever is appearing on the right side of the equal sign, that will be taken as a value, not as a variable. Area equal to A star B simply means that to the variable area, on the right side, take the value of A, which is 5, take the value of B, which is 4, take 5 into 4 and put it inside area. Okay, on the right side of area, there is no A star B. On the right side of area, there is only 5 star 4. That's why the value of area is unchanged. If you want to evaluate again, you need to again write area equal to A star. Then only the value of area will change. Copy to Google document for try. Okay, I hope that you have already tried. But if you want to create a function like if area is equal to A star, that also can be done. That we will probably deal with that later. Okay, so this is how we assign values to variables. Now, just like we have already seen a list. Okay, this is a list. For example, suppose that I write. So should I write even numbers, some even numbers. Remember that when I try to create a variable name, I should not use space in that, but instead of that I can use underscore. To create variable names, I can use a small letter, capital letter, underscore, numbers. But variable name should not start with number. So these are the conventions. Can include lowercase, uppercase, letters, numbers, underscore, but should not start with numbers. No other character allowed. Okay, even numbers. Suppose that I define even numbers, the variable name to be even numbers, and I include some even numbers there. 2, 4, 6, 8, 10. Okay. Now, suppose that I want to find the sum of all these things. Had it been in a programming language, it would have been difficult, but in SageMath, it's really easy. You need to just apply the function sum to even numbers. Print sum even numbers. That's it. 30. In the Google document now. Now, to find out how many numbers are present in a list can be done using the command called length, len, length of a list. Print length of even numbers. See, if you are doing in the Sage cell server, in every Sage cell, you need to put this on the top. Otherwise, Sage cell will say that the variable even numbers is unknown to it. See, here I am not doing that basically because I am working in a Sage worksheet. Okay, Jupyter IPython notebook kind of worksheet. In that, whatever is typed on the top cell will be, the value will be available to whatever command that we are typing below that. Okay, I am doing it in a Sage worksheet or IPython notebook. But in the Sage cell server, SageMath cell, this is not going to happen. So even numbers you need to type again and again inside that cell. Now, length of even numbers. What is meant by length of even numbers? That's 5. So there are 5. So how do we find the arithmetic mean of these even numbers? It's very easy because sum of even numbers divided by number of numbers, which is length of even numbers. Print sum of even numbers by length of even numbers. That's it. I'm just removing this. Length is the command that we use. So arithmetic mean is therefore 6. Copied and pasted to the Google Sheet. Google document, in fact, not sheet. Okay, now for defining even numbers, you don't have to actually do something like this, but instead of that, you can try something like this. Suppose that you want to find out the sum of all even numbers in the range 2 to 100. Okay, which is an arithmetic progression. Suppose that you want to find the sum of all even numbers in the range 2 to 100. Instead of typing 2, 4, 6, 8, 10, 12, 14, etc. Instead of that, you can simply type 2, 4, comma, dot, dot, comma, 100. Let us see what exactly this is. Let us print and see what is meant by this notation. I used comma, dot, dot, comma. See here. So this is actually an operator in SageMath. What happens is, the difference between the first two numbers is taken, means the second number minus first number is taken, and that difference is added to 4, and up to 100 numbers are reached. Okay, this is the way to create lists using some formula. Updated the Sage cell, Google Sheet, Google document. Odd numbers also can be created exactly in the same way. Odd 1, 3, 100. So up to 99. Okay, this is how we create lists directly. But instead of even that, you can do something else also. Odd numbers equal to something like this also you can do. Range 1 to 100 with a gap of 1, with not a gap of 1, with a gap of 2. Odd numbers means 1 to 100 with a gap of 2. So now print odd numbers. Oh, sorry. Range. Oh, sorry, what is this? Okay, you need to use list all the numbers in this range. It's a list. Sorry. Yeah. List of numbers in this range. The Google document is now updated. I am pausing for a while so that whoever is trying to do these things using the Sage Cell server can copy and paste the command. That's why I am pausing for some moments. Okay, this is how we create list. This is how we create list, and this is how we manage list. So the product also will work. Product. Maybe we can sample list. I am defining the list to be 1 or 2, 3, 5. Product.
ये हमारा नजरिया इनका प्रोडक्ट लिखा है ना ये से सत्यवादी
Hello, can you please mute?
आगे नहीं पीछे
Okay, so product sample list. So PROD, that's what we used. 30. 2 into 3 into 5 is 30. So the product command we can use, and you can in fact create some squares also if you like. For example, first 10 squares. I am just giving the name like that. It's not necessary. Just first squares. Not to make it much more complicated. So for getting squares, what I am going to do is I am creating a list first of all. Okay. First numbers. 1, 2, say up to 20. First squares of this 1 to x to 20. For this I am trying this x square for x in first numbers. So first squares will consist of x square, where x is coming from first numbers. This is just like set notation. Now print. Yeah. 1, 4, 9, 16, etc. up to 400. Squares of all the numbers. The Google Sheet is now updated. Okay, and we can apply any number of operations here like this. For example, suppose that we define first cube, we can define to be x cube. Oh, The spelling is wrong, so that's fine. X cube. You can define any polynomial in fact. Or even some pi values also you can define. Angles. Suppose that we define the angles to be pi by, where should we start? Pi by 6, pi by 4, pi by 3, pi by 2. Suppose that sine angles, I'm just writing sine angles here. So sine of x for x in angles. Let's see, maybe we can, instead of print, we can even use show. So that will appear in a better format. Updating the Google Sheet, updated. Okay, this is how we perform operations on lists. So simply using list, we can create another list. Okay, now this is not actually the only one way to create another list. For example, suppose that we want to find one list, and suppose that we want to take only half of that list. That's also possible. Okay, for example, suppose that we have taken first 100. First 100 equal to 1, 2, 100. Directly from that particular list, we can find first 50. How to do that? Just take first 100. Remember that the numbering is from 0. This 1 is actually the 0th element, 2 is the first element, etc. So first 100, if I use the first 50. Okay, suppose I use up to 50. Let us see what this is. See, colon 50 means that take all elements up to 50. Now, but instead of that, suppose that we try 0 to 50. What will happen? 0 to 50, exactly the same thing. Suppose now we try, instead of defining another variable, suppose instead of doing all these things, first 100, suppose I define the 9th element to the 50th element. What will happen? 9th element to 20th element. What will happen? 9 to 20. So I am getting 9th element is, okay, 10th element means 11 onwards. 11 to 20. So this way also we can define. And what is the output of this? Can you guess? What is the output of this? Any guess? It's here, starting from 51, not from 50. The first element is, so 50th element means the 51. Okay. Starting from the 51th element, that first element is not taken. After that, up to the last element. Okay. Let me copy and paste this to the Google document for you to try. So this is how we can make newer and newer lists using the old list by slicing. So this is known as slicing. Okay, this 0 to 50, first 50, 0 to 50, this command is known as slicing a list, because we are actually taking some part of the list outside and creating a new list. That's known as a slicing of the list. This is a very common operation in Sage mathematics as well as in Python programming, of course. Okay, these things we commonly do in all these things. Now, another thing is variables we have already seen, how to assign values we have already seen. Now, let us try to do some more extra computations using this SageMath. For example, trying to find the area of a triangle, but as not as a simple problem, but we will try to define an area function. Okay, we will try to define an area function, but before that we try to see how to do the area computation directly without using any function kind of stuff. Okay, let us see, using the three sides, the formula that we are going to use is given the sides a, b, c and s is equal to a plus b plus c by 2, the formula is square root of s into s minus a into s minus b into s minus c. That's the area formula that we are going to use. A is equal to 10, b is equal to, say, I don't know whether this will create a triangle, that's something confusing. Okay, maybe I can use 5, 3 and 4 and 5. Definitely there will be a triangle like that. 3, 4, c equal to 5, because that should form I think a right triangle, right? 3, 4, 5. 3 square, 4 square, that is 25, that's 5. Okay, I guess so. So S is equal to A plus B plus C by 2. Area equal to square root of S into S minus A into S minus B into S minus C. Print area. Maybe triangle area we should put T area. Area is 6. Copying and pasting. Okay, now instead of that, let us try to make a function. What is meant by a function? So simply, if you put triangle area function and if you ask for t area of 3, 4, 5, automatically the computation will be performed and the answer will be given. Okay, like this. Okay, DEF. Sorry. The function is defined like this: DEF, T area, A, B, C. This is how we define a function. Now, look at the indentation. Automatically, from the left margin, some space is left. Actually, 4 spaces are left. 1, 2, 3, 4. Sorry, this is not required. This we need to feed. So, instead of printing, we will ask for returning. That's the difference. Now, how to make use of this? Print T area of 3, 4, 5. So automatically, what will happen is when you use this T area command, automatically the system, the SageMath will send the values 3, 4, 5 to this ABC. So A will become 3, B will become 4, C will become 5. S will be computed. T area will be computed like this. Return T area means, so we are asking for T area from this from this print command. So the value of T area will be computed here and returned back to this place. So the area will be printed. This is known as a function. So area is 6. Now, once again, if I want, so 6, 8, 10, Another one. Copying and pasting. Please try. The indentation you need to be really careful about. See that inside the definition of the T area function, everything is given some spacing. Everything is given 4 spaces from the margin. After that, again the control is pushed back to the left margin. I cannot put a single space like this here. This will not work. See, you are not supposed to, you are not expected to, you are not allowed to. Given a space in the beginning of any line must be close to the margin. You can give space provided that you are inside a define, because these lines are part of the definition, therefore must be at a distance of 4 space from the left margin of the def keyword. Four spaces left from the left margin below def keyword. Keywords are reserved words. They are reserved words. I'm just updating the Google. Just updating the Google Sheet. Update. So this is the triangle area function. You can define any type of functions here. And yeah, one important thing I forgot to mention is that whenever you are inputting some value inside the triangular, the circular sine function, cos function, etc., you need to put it as radians. Degrees will not work. For example, if you put sine 90 and numerically approximate. Yeah. You will not get 1 because this is in degrees. You need to convert it into radians. Radians will it work? A radian. I don't know whether radian is actually the word or not even that. So that is also not going to work. 90 into how do we convert? Pi radians is 180 degrees, right? So 1 degree is okay, you need to multiply with pi by 180. This is correct? I don't know. I think so. 1. Yeah, that's the only way. And maybe if you want, you can define a function like this. Define radian. This is the definition. Radian, degrees given, convert to radians. That's the our aim. That's what our aim is. So how do we convert? Return degree star pi by 180. After the return, you just see that the margin is again shifted to the leftmost margin. Sine radian 90. Print. One. Again cos radian, convert to radian 45. 1 by 2. square root 2. So square root of 2 into 1 by 2, which is essentially 1 by root 2. Tan 45. Okay. Now the inverse trigonometric functions also should like this, work like this. Print. Inverse trigonometric functions are usually denoted using the a symbol before that. A sign or arc sign. A sign 1 by 2 pi. Okay, let me copy paste. The function definition, copying and pasting. Radian function definition. Using it for tan, and see that the result is always in, if you use the sine inverse trigonometric functions, the results are always given in radians. Copied and pasted. Please try. Okay, so I hope that you are all comfortable with whatever commands we have discussed so far. Okay, the feedback link, shall I post this to the YouTube streaming as well?
Sir, yes.
Okay, I'll do that. So these are the very basic things that we discussed so far. Now we are going to see something related to, okay, I forgot to actually mention that there are a few other data types available in Python. Data type in the sense that we have, in mathematics, we usually use objects from different sets, like integers we use, real numbers we use, rational numbers we use, complex numbers we use, etc., right? In SageMath, all these things are already available, like real numbers are available, integers are available, rational numbers are available, complex numbers are available, several things are available. In addition to that, certain programming related concepts like list is also available. We have already seen how to access a list, and we can actually modify list also. Okay, that's actually going to be something really useful when we are performing certain computations, that we need to know that how to modify a list. Okay, I'm just coming back to the list once again. So I'm not going linear always in the first few lectures. I will be going here and there, so that if I feel that something important is missed, then I will be going to that part. Okay, please don't expect me to be linear, going straight away on a straight line. But after 1-2 lectures, most probably we will be going linear. Only in one particular topic we will be sticking, and that particular topic we will try to cover as much as possible. These beginning things we cannot go like that. I will try to introduce whatever basic things are required for future future sessions of this particular workshop. Okay, I'm not going linear, that's what I'm saying. So I wanted to say that modifying list, sample list, 1, 3, pi square, 5 by 2 rationals, e cube, anything can be included. Okay, so this is a list. Now we have seen that the first element in this list is 1. For example, print sample list 1. or sorry, first element is accessed using 0, the index 0. So this 0 inside the square bracket is known as an index. How the output is found. So now let us try to modify it. Sample list. Suppose that I want to modify just the first element and call it as first element I am modifying to -1 and see, print sample list the entire thing. You can see that it's getting modified. Okay, now sample list append. Let me try. E cube is already there. 4.5. Okay, try and print sample list once again. See that the list is now expanded with an extra number, 4.5. Okay, copying and pasting. Yeah, copied and pasted. This is how appending an element, right? Now, inserting an element is also possible. Insert. I don't know how exactly to specify that location. I'll type. Insert, where to insert, maybe at the first position itself, that's 0th position. Remember that the first element is now -1. At the, let us insert at the 0th position -10 and print it once again. Oh, sorry. Inserted. -10 is inserted at okay, the meaning of this command is -10 -10, that is 0, inserted to the 0th position. Now we can delete also similarly. You can see that -10 is inserted here, 4.5 is at the last position. So if you want to delete, this is what is the length of the list now? Let us see length of the list. The length of the list is now 7. Okay, now if you want to remove a value, suppose that 4.5 we want to remove, we can remove it like this. 4.5. Now again printing. What's happening? After removing 4.5, the list becomes -10, -1, etc. But okay, we can print some extra messages also along with this print, so that the message will become actually meaningful. Okay, that line will become meaningful. List after removing 4.5. So that how did I do that? I enclosed list after removing 4.5 inside a quotes. After that, after closing the quotes, I put a comma, and after that sample list. See the output. So the comma is not appearing again here. See this, there is no comma. Okay, I'm copying and pasting to the Google Doc once again. You can try all the commands in one stretch. I copied and pasted everything in one stretch now. Okay, this is how we remove an element. Now, there should be actually one confusion. Okay, I will tell you that. I will copy and paste this once again. One, suppose that I put one more 3 here. Okay, one more 3. So if I apply the remove command once again, suppose that I remove this 3. So which 3 will be removed? There are 2 3s. This 3 here and this 3 here. Okay, let us see what will actually be removed. We don't know what exactly is going to be removed, or both will be removed, we don't know. Print. The first 3 is removed, but even that is not guaranteed because it depends on the SageMath system that which one is actually removed. So 1 3 is removed. That's the only thing we know. Okay. Okay, now instead of removing, so if you want to remove all the items, you need to be really careful about, because using the simple remove command, you cannot remove all the items having the same value. Now, if you want to remove an item using index, okay, suppose that we want to remove an item using, okay, I'll copy paste this first so that you can try it. Copied and pasted. You may try. Okay, an extra command I used here, sample list delete. So what is the purpose of sample list delete? DEL. Sorry. What I did. Okay, but instead of that, sorry, I did a mistake here. Delete. Instead of that, let me just try the other way. Delete sample list 1. And let us see now. Yeah. So delete sample list 1 means that the element with index 1 should be removed from sample list, deleted. Now you can see that the element index 1 is this. This 1 is 0 index, this is 1 index, this is 2 index, this is 3, this is 4, this is 5. The first one is 0th one. Number index 1 is second element actually, which is 3. This is removed. So this is delete. So delete uses the index. Remove uses the value. That's the difference. Okay, delete uses the index and remove uses the value. That's the basic difference between these two things. Now you may be probably thinking that the list can the list contain anything other than numeric values? Yes, a list can contain anything actually. So animals, for example, say animals is equal to cat, but in quotes. Remember that they are in quotes, double or single, whatever. So whatever code you are using to open in the beginning, the same code you should use to close it. Dog, elephant, etc. So print animals 0. So cat will be printed, and we can mix it up. Animals numbers equal to 1, 3.4, 5 by 2, mixing it. Now we can have animals and numbers together in a single list, like this: animals, numbers. So a list can contain again lists. So this inside the list, again there are a few elements. Okay, now how do we access cat from this AN? How do we access cat from this AN? So this is actually, this is the 0th element in AN. This is the 1st element in AN. Okay, so this is the 0th element, and inside the 0th element there is cat as the 0th element of that particular list. So if you ask to print AN 0, 0, so what will be printed? Cat will be printed. This is cat. Now if you ask to print AN 1, 1, 3.4 will be printed. Okay, so you can club list in many ways. And another interesting structure available in SageMath is something known as a tuple. A tuple is nothing but it's more or less similar to the list. But the thing is that you cannot change the value inside a tuple. So tuples are usually used for denoting coordinates in mathematics. For example, x my coordinates equal to. Tuples are enclosed in ordinary bracket. 1, 2, 3. Okay. Print. Okay, sorry that I did not probably copy paste this delete in the Google document. Let me do that. Let's copy paste it. This one and this one, and now this one. Done. Everything copy pasted to Google document. Now the important thing about my coordinates, the tuple, is that you cannot individually change the elements inside that. For example, previously we have seen that first element in that list can be simply reassigned with something else, but this is not possible here. My code 0. Suppose that I want to change the 1 to 2. Okay, suppose I assign 1 to 1.5, say. This is not permitted. Tuple object does not support item assignment. Item means the elements inside that list. That is not permitted. Okay, that's the difference between tuple, and usually, mainly tuple is used for denoting coordinates or something which. Okay, of course you can change my coordinates entirely. That's possible. This is allowed. My coordinates. Sorry, I'm copying and pasting it here. My coordinates equal to 1.5, 2, 3. Entire changing of the value is permitted, but individual item assignment is not allowed. That's what it says. Okay. I think whatever we were supposed to discuss today, something a little bit overly also we have discussed, like going to the trigonometric functions, which was not intended. Now, most probably tomorrow we will try to discuss something related to more basic functions like logarithm function, and some other extra functions like and some basic using conditionals like stuff. I think these are the things that we have intended to discuss tomorrow. And if there are any questions, you may please ask now related to whatever we have discussed today, or some clarification is required, or something you want me to discuss again tomorrow. Please, you may ask.
सर वो स्पेस वाला कंसेप्ट लाइक स्पेस हर लाइन में छोड़ना पड़ेगा या फिर कब?
Sorry, space is to be?
Sir, I wanted to ask कि we left some space in between the lines now.
That's not necessary.
Okay, sir.
In between the lines, you need not leave space. You can leave space, there is no problem. But to the left margin, you are not supposed to leave any extra space. Towards the left margin, you should not leave. That is not allowed. Towards the left margin, leaving the space is allowed only for the indentation purpose. We have already seen that while defining a function, the triangle area function we defined, inside the def, just below the def, we left uniformly 4 spaces. That is also not random. Uniformly we left the space. We will see more examples. We will see more examples in which the spacing, we will discuss that how to leave spaces and how to exactly measure the space that we have to give. We will discuss again. We will see it again. Okay, thank you. Any other questions?
Sir, is it possible to share this Jupyter notebook to us?
Possible to save means what?
Possible to share this Jupyter workbook that you have done in this today's class?
Share with the participants?
Yes, sir.
Yes, certainly I will do that. Certainly. I think we already have a WhatsApp group. I guess that you are also a member of that WhatsApp group, right?
Yes, sir.
So I will compress this file as a zip file, and either I will compress it as a zip file and share it in the WhatsApp group itself, or otherwise I will upload to my Google Drive and share the link. I'll do that.
Okay, sir. Okay, sir.
Okay, but what I guess is that if you try to install this Sage in your own system and try to go along with me using the Google Sheet, I'm copying and pasting everything in the Google Sheet. That'll be much more easier and faster. You will be able to understand. You will be able to ask. Okay, that also you please try to do. If there is nothing else, maybe we can stop today's session, or please, the coordinator may please say.
Okay, sir. We can meet tomorrow, sir.
Tomorrow at the same time, right?
Okay, sir. Okay.
Okay.
Thank you, sir.
Okay, then tomorrow's YouTube link I will create and share with you tomorrow morning, sir. Okay.
Okay, sir.
Thank you.
Okay.